All right, so this is the second half of E2.7 combining functions, which talks about composition of functions. So in the last video, we went over summing functions, subtracting functions, multiplying functions, and dividing functions. What we're going to do in this little piece of the lecture is we're going to take a function and stick it inside the other function, okay, which is called composition of functions. So we write this, it's called f composed with g. If it's f composed with g, we write it as f and then an open circle g of x. Okay, this is our notation. What this means is whichever function is closest to the x, that's the input function. So in other words, this is the same as f, and we're sticking the g function inside of f. Okay. Same thing if we do g composed with f, that means we're taking our g function and we're putting f inside of it. Okay, again, f is the closest one to my x here, so f becomes my input. So g evaluated with f of x as its input. Okay, so if we want to look at a function machine to try to help us understand this, we take our domain values, okay, which is our x's, and we input it into our g function. So that gives us g of x. Okay, and then that becomes our input into the f function. So we end up with f of g of x to get our output, which again is our y value. Okay. So when we look at the domain of these compositions, this changes a little bit. Just like before, I need to identify what's the domain of my f function, what's the domain of my g function. Whichever one is the outside function, that's the domain I worry about last. I always start with my input function because I have to worry about what I can put into that function is my starting domain, and then I modify it for the end result. Okay. So in other words, what this means is, let's do given f composed of g. Okay. So if we're finding this one, we start with the domain of g, because that's the one that's getting put inside, okay, and exclude any restrictions that f may add, okay, to our domain. So whatever the first function is, the one that you're putting inside, you start with that domain, and then once you've created your new function, if there's a variable denominator or an even root, then you modify that original domain as such. Okay, so let's go ahead and look at some examples. Here we want to go ahead and find f composed of g and g composed of f of both of these functions and state their domain. So the first thing I want to do is go ahead and list their domain. F of x is x squared. This is a parabola. Okay, parabolas don't have any domain restrictions, so this is negative infinity to infinity. Okay, my g of x, for my domain of g, this is just a straight line, right? Straight lines don't have variable denominators or even roots. So on both of these functions, I have all real numbers as my input. So when I compose f composed with g of x, what this means is I'm taking my f function and I'm plugging g into it as my input. Okay, so I'm going to go ahead and write out here what my g function is. It's x minus 3. So x minus 3 is what I'm putting into my f function. Now my f function says to take my input and square it. So input squared. My input into my f function is actually my g function, which is x minus 3. Okay, and then we just simplify. So this is the same as x minus 3 times x minus 3. So we FOIL x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. When I combine like terms, I get x squared minus 6x plus 9. So this is my f composed of g function. Notice I start with my input domain, which here is my g of x. My input domain is all real numbers, so that's what I'm starting with. And then I look at my final result, which is x squared minus 6x plus 9. Notice I don't have a variable denominator, and I don't have an even root. So that means that the domain of f composed of g is still negative infinity to infinity. Okay. All right, let's look at the other direction. Let's do g composed of f. When I do g composed of f of x, this time I'm sticking the f function inside my g function. Okay. So in other words, I'm sticking into g my f function, which is x squared. Okay. My g function is x minus 3. So it says to do my input minus 3, which here my input is x squared. Now I don't have anything going on outside my parentheses, so I can just drop them. So this means that g composed of f is just x squared minus 3. Okay. I start with the domain of my inputted function, which here is f of x, which is all real numbers, and then I look for additional exclusions. Here, once I got my final result, I didn't have a variable denominator and I don't have an even root, which means that my domain of g composed of f should still be negative infinity to infinity. Okay? Kind of makes sense? Let's look at another example. Okay. On this next page, if you notice, I actually put the exact same functions as the one I just did. So we don't want to do that. We're going to change these functions. Hold on just a second. Yeah, let's go ahead and change these. I'm going to make f of x, let's do f of x is equal to 1 over x. And let's do g of x is equal to the square root of x. Okay, so mark these out. Okay, so first thing we want to identify is what is the domain of each of these functions. Notice f of x, I have a variable denominator. The denominator can't be 0. So I set the denominator not equal to 0 and solve, which here, that just means x can't be 0, right? If x can't be 0, then that means that the domain of f would be negative infinity to 0, and then 0 to infinity. So basically everything except 0. When I look at g, g is a square root, which means whatever my radicand is, or anything under my square root, has to be greater than or equal to 0. Which means that my domain of g is 0 to infinity. Okay, so these are a little bit more restrictive than the last example, so let's go ahead and work it out. I want to find f composed of g and g composed of f. So the first one, I'm going to do f composed of g of x, which means I'm sticking my g function inside my f function. Okay. So inside my f function, I'm going to be putting in the square root of x. Since the square root of x is my input function, that means I'm starting with my domain of g, which is 0 to infinity. Okay, so that's what we're starting with. And then if we incur more restrictions, we'll take those out also. Okay, so my f function says to do 1 over my input. Here my input is the square root of x. Okay, so this is my f composed with g function. Now in MyMathLab, it won't let you enter a radical in the denominator. So I'm going to go ahead and rationalize the denominator. All that means is in order to get rid of this radical, I would need to square it. So I'm just going to multiply by the square root of x, because that basically squares it. But if I do it on the bottom, I have to do it on the top. Okay, so I get the square root of x all over the square root of x squared, which is just the square root of x over x. Okay, so this is my f composed of g function, and then I want to find my domain. Okay, I'm starting with the domain of g. Use g domain. Okay, which is 0 to infinity. So I know I can only use 0 to infinity. So I look up here, and on top I have a radical an even root radical, which means that whatever's underneath it has to be greater than or equal to 0, which notice I already have an accommodation for that with my domain of g. The only thing I haven't accommodated is this denominator, okay? This means x can't be 0 because here my denominator, if I plug 0 in for x, I'd get undefined. So I take my original domain of g, which is 0 to infinity, and I basically take out the 0. So instead of using a bracket here, I'm now going to use a parenthesis since we can't include 0. So this means that the domain of f composed of g is parenthesis 0 to infinity. Okay, I can still use 0 to infinity, I just can't use the actual 0 value because now I have an x in the denominator. Okay. All right, let's look at g composed of f. If I look at g composed of f of x, this means I'm taking my g function and sticking my f function inside of it. Okay. So in other words, I'm doing g evaluated at 1 over x because that's my f function. Now since my f function is the one being put into, I use that domain first. So I'm going to use my f domain, which is negative infinity to 0 and then 0 to infinity, which means I can use anything except 0. Okay. So when I plug this into my g function says to take the square root of my input. When I take the square root of 1 over x, the square root of 1 is just 1, and then the square root of x is the square root of x. So notice we actually ended up with the same thing we had on the last function. Again, we need to rationalize the denominator because we can't enter radicals in the denominator in my math lab. So I'm going to multiply on top and bottom by the square root of x, okay, which gives me the square root of x over the square root of x squared, which just becomes the square root of x over x. Okay. So I already know we started out with the domain of f, which was everything except 0. Okay. So that accommodates this denominator here. I know I can't plug 0 in, so I know the denominator is never going to be 0. However, I have the added stipulation of this top piece, which is a radicand from an even root, so we know that x has to be greater than or equal to 0. So now not only can we say we can't use 0, but now we can only use things that are greater than or equal to 0. Okay, so that cuts off this whole last piece of my domain over here. Okay, I can't use that part because I can't plug negatives into the top, which means that my domain of g composed of f is now going to be 0 to infinity, right? Because it can't be 0 from the denominator, so I can't use a bracket on the 0, and it has to be strictly positive, so that means from 0 I'm going out to positive infinity. Okay? All right, let's look at one more, and then we'll look at evaluating compositions. Okay? So again, I want to identify the domain of each function. Okay. On this first one, we have an even root. Remember, with even roots, the radicand has to be greater than or equal to 0. So x minus 3 has to be greater than or equal to 0. So I'm going to move my 3 to the other side, which means that x has to be greater than or equal to 3, which means that the domain of f is 3 to infinity. Okay. For g, notice I don't have a variable in my x and my denominator, and I don't have an even root, which means that the domain of g is negative infinity to infinity. Okay. So let's go ahead and do f composed with g, which means I'm taking g and placing it inside f. Okay. So in other words, I'm putting g, which is x minus 3 over 5, inside my f function. Okay. So notice if g is my input, okay, I'm using the domain of g, which means right here I can plug in any number. So I'm starting out with any possible number. The only reason I would have a restriction on my domain is if when I plug it into f, I end up with a variable denominator or a square root. Okay. So let's go ahead and plug it into f. F says to take the square root of my input minus 3. So here my input is x minus 3 all over 5. Okay. And now I just need to simplify. Okay. So I'm going to go ahead and get a common denominator, which would be 5, right? So that I can combine all this stuff. So I'm going to write this as 3 over 1, and I'm going to multiply it on top and bottom by 5. Okay. So I end up with the square root of x minus 3 minus 15 all over 5, which gives me the square root of x minus 18 over 5. Okay. Now, if I were to break this up, this gives me the square root of x minus 18 all over the square root of 5. We can't enter a square root in the denominator, so just like before, I'm going to go ahead and rationalize my denominator, by multiplying on top and bottom by the square root of 5. Okay. So what that gives me is, let me come down here. Oh, let's come over here. So that gives me the square root, and I'm going to go ahead and distribute that 5 to my x and my 18. So I get 5x minus 5 times 18. Let me use my handy dandy calculator. 18 times 5 is 90. 5x minus 90 all over the square root of 25. Or in other words, the square root of 5x minus 90 all over 5. Okay, so this is my composition function. Okay, and then I just have to make sure that my domain hasn't changed. So notice my first domain I started with was the domain of G, which is all real numbers, no restrictions. Now when I look at my end result, I am going to have restrictions because I have an even root. Okay, anytime I have an even root, my radicand, which in this case 5x minus 90, has to stay greater than or equal to 0. So I'm just going to go ahead and solve to find my restriction. So I move my 90 over, which means 5x has to be greater than or equal to positive 90, and then I divide off my 5, which tells me that x has to be greater than or equal to 18. Okay, so my new domain here, my domain of f composed of G, is going to be from 18 to infinity. Okay, now let's do the other direction. Let's do G composed of f of x. So this time I'm taking my f of x and plugging it into my g function. So my f function is the square root of x minus 3. That's what I'm plugging into my g. So that means I'm starting with the domain of 3 to infinity, because that's the domain of my f function. So I already have a restrictive domain. Now once I plug it in, I just need to make sure it didn't get more restrictive. Okay. So when I plug this into my g function says to take my input minus 3 all over 5. My input here is the square root of x minus 3. So I end up with the square root of x minus 3 all over 5. Okay. Now I can't combine anything because that first chunk is under the radical, the negative 3 is not, and I don't have a radical in the denominator, so this is really as simplified as I can get. Okay. So now I just need to list my domain. Notice here, I didn't incur any new domain restrictions because the square root of x minus 3, we already have that stipulation already here saying we have to start from 3 to infinity to accommodate that. And then we didn't get any other radical, and we didn't get a variable denominator. So this means that my domain of G composed of f is going to be 3 to infinity. Okay? All right, so that was all just figuring out the new function, how to go from one function to the new function by taking a function and plugging it into the other one. Okay, or the first one into the second one. So this is coming up with new function and finding new domain. What we're going to look at now is evaluating these functions. Okay, so in order to evaluate these functions, we work it out the same exact way. Now, before when we did addition, subtraction, multiplication, and division, we just figured out what f of that number is and what g of that number is, and then subtracted, multiplied, divided. Here we can't do that because we're plugging one into the other. So we have to do it step by step. Okay, so they give us two functions, and they want us to find f composed of g evaluated at -8. So what that means is we're going to take f and we're going to plug in g of -8. So my input goes into my g function first, and then whatever that equals, that's what we'll plug into our f function. Okay, so the first thing I need to find is I need to figure out what g of -8 is. Okay, g of -8, if I plug -8 into my g function, I get -8 plus 5 all over 3, which gives me -3 over 3, which is just -1. Okay, so that means now that I've simplified inside my parentheses, I'm doing f evaluated at -1. Okay, so now I need to plug -1 into my f function. Okay, my f function says to take the square root of my input plus 3. So here I'm doing the square root of -1 plus 3, which just gives me the square root of 2. Okay, so we plug that number into our input function, figure out what it is, and whatever that is, then we plug that into our outside function. Okay, so let's look at another one. Now we're doing g composed of f evaluated at 13. So the first thing I need to do is stick 13 into this f function. Okay, so I'm going to do f of 13, and whatever that equals, that's what I'm plugging into g. Okay, so here to find f of 13, I plug 13 into my f function, which my f function says to take the square root of my input, which is 13, plus 3. So that's the square root of 16, which is 4. So 4 is what I'm going to be plugging now into my g function. Okay. My g function says to take my input plus 5 all over 3. And here my input is 4. So 4 plus 5 all over 3 gives me 9 over 3, which is just 3. Okay. And then the last one they want me to find is g composed of f evaluated at -8. So again, first thing I need to do is put -8 into f, and then whatever that is, I'll put it into g. So I'm doing g composed of f evaluated at 8. Okay. So f of -8, when I plug -8 into my f function, I get the square root of -8 plus 3. Now, I have a problem here, right? Because what this gives me is the square root of -5. And remember, our functions we have to take into consideration their domain, okay? We're only using real numbers. So here, I can't evaluate the square root of -5 without using complex numbers or imaginary numbers. So this is not in the domain of f, so it's undefined. Okay, if it's something I can't evaluate, then the solution to this is just undefined. Okay, I can't plug in a value into something that's not there. Or in other words, if I look up here at my f function, notice my radicand would have to be positive. So the first value of x I could plug in here is -3. So here my domain would be -3 to infinity. Okay, and this problem was asking me to plug in -5, which is not from -3 to infinity, so I can't evaluate it. Okay, so we leave it as undefined. All right, so I want to show you the same idea of evaluating functions using pictures like we did in the last part of this section. Okay, so it says use the following to find f composed of g of 3. So again, I'm going to go ahead and write f composed of g evaluated at 3 means I'm doing f evaluated at g of 3. So the first thing I need to do is figure out what g of 3 is. Okay. To find g of 3, I go to where x equals 3, which is here, and I trace it up to my g function because I'm plugging it into g. G on this picture is my parabola, so when I trace it up till it hits, notice its y value at that point is 4. So that means g of 3 equals 4. So 4 is now what I'm going to plug into my f function. Okay, so I go to where x is 4, which is here, and I trace it up to my f curve, which hits here. Okay? And my y value at that point is 1. So f composed of g evaluated at 3 is positive 1. Okay? Let's look at another one. Same idea, f composed of g evaluated at 3 means I'm taking g of 3 and plugging that into f. So the first thing I need to do is figure out what g of 3 is. So I go to where x equals 3, which is here. I trace it down to my g function, which is this line, and its y value at that point is negative 1. So negative 1 is what I'm going to plug into my f function. Okay? To find f of negative 1, I go to where x is negative 1, which is here, and I trace it up to my f curve, which is here. And notice my y value at that point is 2. So f composed of g evaluated at 3 is 2. Okay? All right, on the next page there's 2 for y'all to try. I'll give you a minute to do those and then we'll go over them. Okay? All right, so on this first one, we're taking our f function and our g function and we're composing them evaluated at 0, which means I need to take g of 0 and whatever that equals, plug it into f. So when I look for g of 0, I end up with 2, which means I'm plugging 2 into my f function. My f function says to take my input squared and add 1. So I do 2 squared plus 1, which is 4 plus 1, which gives me 5. Okay. The second problem here is asking me to find the function. Okay. If there's a value here, that means we're evaluating. If there's an x, that means we're finding a new function. Okay. So we're going to find the function g composed of f, which means I'm taking my f function and plugging it into g. Okay. My f function is x squared plus 1, so that's what I'm plugging into g. My g function says to do my input plus 2. Here my input is x squared plus 1. I can drop my parentheses, combine like terms, which gives me x squared plus 3. Since the domain of both of these functions was all real numbers, when I combine them, since I didn't get anything funky like a variable denominator or an even root, my domain is still all real numbers, negative infinity to infinity. Okay? On the second one, same idea. We're finding f composed of g of negative 1, so this one is evaluating. Oops, I didn't even spell that right, did I? Evaluating. Okay. So I'm going to plug negative 1 into g, see what that equals, and then plug that into f. So when I plug negative 1 into g, I end up with 0. So 0 is what I'm putting into my f function. My f function says to square my input, multiply it by 2, and add my input to it. So when I put 0 in there, I end up with 0 plus 0, which is just 0. Okay. The second one, I'm composing g with itself, which is completely legal. And notice it's evaluated at x. So this means I'm coming up with a new function. Okay. Creating new function. So when I compose g with itself, notice my domain is negative infinity to infinity. So I'm taking my g function, which is negative x minus 1, and plugging it back into the g function. The g function says to do the opposite of my input minus 1. So I put my input in, which is negative x minus 1. I distribute that negative, which makes it a positive x, and a positive 1 minus 1, which leaves me with just x. Since I didn't incur a new variable denominator or radical, then my domain is still negative infinity to infinity. Okay, so that's the end of all the 2.7 material. So you should now be able to do the second 2.7 homework assignment, which is in my math lab. No worksheets, just a regular assignment. Let me know if you have any problems.